Unit 8, Absolute Value Inequalities. That's today. And so just like we did equations, there's going to be two inequalities when we're solving. It's just you're going to have to always put your answer on a number line or interval notation or set notation. Okay? So when you're thinking about absolute value, if you think about something, the absolute value of x is greater than 5, what you need to think about is it could be at 5, it could be at negative 5. So you're saying the distance from 0, open circles here, the distance from 0 is going to be bigger than 5. So that's why it's going to go out like this. So distances over here are bigger than 5, and distances over here are bigger than 5. And if you went the other way for it, the absolute value of x is, say, less than or equal to 1. Okay, this is negative 1, positive 1, and 0. We would color in those circles. And it's everything less than or equal to 1. So this is less than or equal to 1, and so is that. So it's all the connections. So we're going to think about that when we do this. Okay, so the basic properties, or the procedure that you're going to follow is, isolate the absolute value, create two inequalities this time. So instead of two equations, it's two inequalities. And this is the basic thing. The first one is exactly the same, just lose the absolute value sign. And then everything for the second inequality, everything outside the absolute value changes. Both the signs of everything and the inequality gets reversed. Then we solve and we make sure we write our answer correctly. So here we go. Isolate the absolute value. So you look, the isolate value is this little section right here. The 2 is extra, so it's 2 times the absolute value, so I divide to get rid of it. So it's the absolute value of 2x minus 4 is greater than 6. It's isolated, so now we create two inequalities. 2x minus 4 is greater than 6, so exactly the same as the first. 2x minus 4, remember that's inside, so it stays the same. Everything changes outside the inequality. So both of these things right here are outside the inequality, so both of those have to change. Okay, so the inequality gets reversed, and the 6 goes to a negative 6. And then you solve. So x is greater than 5. And x is less than negative 1. Okay, when we're solving this, that's it. Okay, but now we have to make sure we write our answer correctly. So it says solve and graph. So that means the graph, since there's only one variable here, is going to be on a number line. So I like to do each one separately. So I'm going to graph x is greater than or equal to 5. Or just greater than 5, sorry. So here's where 0 would be. Here's 5. So greater than 5 would look like this. Oop. Every time. Sorry. It's an open circle. Okay. Less than negative 1. We'll do that one on this number line. Open circle. Going this way. Okay. Since this is a greater than, it's considered an or equation or inequality. So that means it could be greater than 5 or less than negative 1. Two options, greater than 5 or less than negative 1. So this is your final answer for the graph. Interval notation, you just take that one that you have, this, and rewrite it. Now for the most part, when you're solving this equation, if it's greater than, it's going to be going out. And if it's less than, they're going to be colored in the middle. So this part we don't really have to do. I'm just showing you how it works. This is a lesson, so, you know, you don't have to do every single thing all the time. So to write this in interval notation, we simply go from negative infinity to negative 1, and from 5 to infinity, all parentheses because we have open circles, and we're going to infinity. And since it's an greater than or an or equation, or inequality, we do that. Set notation is really just being able to rewrite these two things, this and this. So that's really all it is. With greater than, it's pretty straightforward. X is greater than 5, or X is less than negative 1. That's our set notation. If you want to get picky and put little curly brackets around it, make it more of a set. There you go. Okay, for this one, I'm just going to do this one so you can see. We have to isolate first. So we got to subtract the 2. That's a 2. 12. This is times 3, so I divide. And now that it's isolated, now I create my 2 inequalities. Now know that I'm looking at this is a less than problem at this point, so chances are when I'm going to graph it, whatever the 2 points wind up being, I'm going to be coloring them in. Okay, I may show you why that is so if you want, or you can ask your teachers or whatever. Okay, so we create 2 inequalities. 2x minus 2 is less than or equal to 4. 2x minus 2, remember everything gets switched, greater than or equal to negative 4. So remember this is greater than or equal to because they switch. Okay, solve each. I guess I'm changing the color, sorry. X is less than 3. X is greater than or equal to negative 1. Okay, so the graph, if we take each one separately, so I'm going to take this one, X is less than 3, or less than or equal to, sorry, I always lose that at some point. Less than or equal to 3. If you do this one, you color in the circle, it's this. X is greater than or equal to 1, or negative 1, looks like this. Okay, problem with this is if we did the same thing we did on the other one, it would be every single number, which it isn't. So what we do is we do the intersection. Where are they exactly the same? So from here to here, they are the same. So between negative 1 and 3, it's colored in. Okay, so as I said from before up here, if it's less than, generally we're going to be coloring it in. If it's greater than, we're going to be going out. Okay, so doing interval notation is the easier interval notation because it's only one thing. So negative 1 and 2 are going to have square bracket, or 3. That should be a 3. Sorry, I'm looking at all this stuff. That should be a 3. Okay, to do this in set notation, a little bit different. Because it looks like this, and they're connected, we say X is between negative 1 and 3 inclusive. So when it's an and problem, you can't write it as 2 inequalities. You have to just write 1 inequality like that. Okay? So then the last one here. This one I just wanted to show you how the coloring in and coloring out can be slightly confusing, and you're going to want to test your values periodically. This is a greater than problem. But once I isolate, so watch me isolate this problem. I subtract 4. Then I divide by negative 2. But if you recall from work with inequalities, when you divide by a negative, you must reverse this guy. So it's going to be absolute value of negative 1 plus x is less than 5. Okay, so now this is, once it's isolated, now I know this is going to be one of these problems where I color it in between. Because once it's isolated, that's when it tells me this less than is telling me it's going to be colored in like that. Okay, so now write your two equations. -1 plus x is less than 5, and -1 plus x is greater than -5. Add 1. X is less than 6. Add 1. X is greater than -4. It's a less than, so truthfully, I can just go right to graphing it. I don't have to do the 2 graphs ever, or the 3 that I had before. I just wanted to show you what it was. So it's 6. X is less than 6. Open circles. X is greater than -4. Open circle. And we color it in. Okay. Interval notation, we just take that mess. We do -4 and 6, and since they're open circles, parentheses. So this one asked for just the interval notation and not the set notation. But let's get picky and just do set notation so you're clear. When set notation looks like this, you say x is between -4 and 6. These symbols right here are always less than when creating this. They never can be 2 different things or greater thans. They're always less thans. So you go in order. So this is the smaller number and that's the bigger number. All right, have a good weekend.